Okay, so it's 1/2 a bracket log base 4 parenthesis x plus 1 plus 2 log base 4 parenthesis x minus 1 close the bracket plus 6 log base 4 x. Okay, so we want to condense this, and when we're condensing, we're going to sort of work outside in. It's like the reverse of doing the order of operations where you're working inside out. So we're kind of reversing everything. So the first thing we want to do is take this 1/2 in front. So that 1/2 is indicating that we have an exponent, or that's well, that 1/2 is, it's going to be an exponent, and it's going to go on like everything. So first, so you can see that clearly, I'm going to actually multiply that through, just so you can see that that 1/2 is going to end up with an exponent on each of these logs, because whatever's in front of the log always ends up as an exponent. So I've just distributed that 1/2 through, and then I'm actually then going to do this 1/2 times 2 in the second log expression there. And then that we end up with no exponent there. So we have 1/2 log base 4 of x plus 1 plus, and then the 1/2 times 2, that cancels. So then we have log base 4 of x minus 1, then 6 log base 4 of x. So now every number that's in front of the log, that becomes an exponent on the whatever you're taking the log of. So all of those are going to go back up in as an exponent. So then I have the log base 4 of x plus 1. Now that's going to have the 1/2 power. Hold on. I know, you were very sad. You're such a sad dog. Okay. Okay, so the middle term doesn't have any exponent, so that's just going to stay log base 4 of x minus 1. And then the last term is going to be log base 4 of x to the 6th. Now, when you have logs and you're condensing, everything that is addition between logs turns into multiplication under a single log, as long as they have the same base. So all of these are log base 4. So I'm going to basically create this big expression with all of those combined multiplied. So that will be x plus 1. Oh, come on, don't escape on me. To the 1/2 power times the x minus 1 times then the x to the 6th. And so now it's a really nasty looking thing, and we can convert that 1/2 power to a square root. What are you doing? Sorry, my dog is on my lap and I don't know what she's doing. But I'm actually going to I'm going to rearrange these just so it's a little easier to read. So we have x to the 6th, then the x minus 1, and then I'm going to put the square root in the back just so that it's clear what's underneath the square root. And so we have a log base 4, and then everything that we're taking that base, that log of, is the x to the 6th times x minus 1 times the square root of x plus 1. And there's not really any way to simplify that further without making it look even nastier. Because if we tried to multiply that x to the 6th through the parentheses, and then if you tried to like multiply the square root part through, it's just not going to look nice. So that is one of the nasty ones that I picked.
Yeah, that is.
I can do another nasty one that's kind of similar. I'll do this one in purple. So let's see, this one has 2 bracket 3, then the natural log of x minus the natural log of x plus 1 minus the natural log of x minus 1, and then the bracket. So we've got that 2 and we've got the brackets. So it's going to be the same sort of step where that 2 in front I'm going to multiply through the parentheses, or the brackets in this case. So I'm going to have 2 times the 3 natural log of x, which is going to be 6 natural log of x. Then I multiply it through the second term, so it's going to be minus 2 natural log of x plus 1. And then I multiply it through the third term, which is going to give me minus 2 times the natural log of x minus 1. Now, all of these coefficients are going to become exponents. So all of those, I'm going to go back up, which gives us natural log of x to the 6th minus the natural log of x plus 1 squared minus the natural log of x minus 1 squared. Now, subtraction is where you create a fraction. That's always division. But when we have division here, we have to do it one step at a time, because if you've got multiple things divided, it's like, well, where do I just create lots of fractions, or how does this work? So whenever I have a subtraction and I need to convert it back to dividing with like a natural log, I do it one subtraction sign at a time to make sure everything is in the right form. So when I combine the first 2 terms, I'm going to have my natural log, and then the x to the 6th is on top, and then x plus 1 squared is going to be in the bottom. And then I have my minus natural log of x minus 1 squared. And we have another subtraction there, so when we're condensing, that's also going to go on the bottom. So that's going to join the x plus 1 squared. So we're going to get a really big fraction inside of here. So I have the x to the 6th. I'm going to have the x plus 1 squared and the x minus 1 squared. So everything that's subtracted ends up in the denominator. And so I just do it one at a time, because sometimes you then have a plus in there in between 2 subtraction signs, and it's just a little easier to make sure you have everything going in the right place. But then that's your answer, and I mean, you can't simplify that any further. There's nothing that inside that fraction that you can simplify by any means. It's just going to look really gross.